Hi everyone. I'm looking here at section 2.1 and wanted to go over with you just some of the introduction for this first section. We're going to begin first of all with polynomial functions. Okay, a polynomial, just in its basic general form, would look like this. F of x equals a sub n x to the n plus a sub n minus 1 plus x to the n minus 1, so forth all the way down here to a sub 0, which will be a constant. So we are in descending order of a polynomial that you probably are used to seeing. Remember that a polynomial in this form has degree n. Okay, so that would be our highest exponent up here. And then we call leading coefficient would be your a sub n. Okay, we can also have something called a zero function. Okay, and a zero function is like this: f of x equals 0. There is why it's called a zero function. And if that's the case, it has no degree and it has no leading coefficient. Okay, so just a couple things to note with this. So if we were in class together about right now, I'm going to erase this so I can have a little bit more room. Give you a second to get ready here. And I might ask the question, identify whether or not we have a polynomial, and then I'm going to have us answer a couple questions with this. So this would be identify polynomial function. Okay, for example, suppose I say f of x equals 4x to the third minus 5x minus 1/2. Okay, and then maybe the name of the game here is, maybe I make a little chart out of this. First of all, is it a function, yes or no? Okay, what would be the degree? And then what would be the leading coefficient? Okay, and I'll give you several examples here. So here's this first one. All right, so we notice that it is in fact in descending order. Okay, it's a degree 3, it's a cubic function. So is it, well, there I just gave it away. Is it a function? Yes, it sure is. What would be our degree for this one? It would be the highest exponent, so that would be a 3. Okay, and then what is the leading coefficient? Okay, leading coefficient right here, and it would be a 4. Okay, all right, let's try another one. Let's say g of x equals 6x to the negative 4th plus 7. 6x to the negative 4th plus 7. So I think I forgot a little definition at the very beginning when I defined polynomial. In that original function, f of x, the generic case, a sub n, x to the n, I had it written up here a second ago. I forgot to mention, kind of important, that n needs to be a non-negative integer. Okay? Funny, I just happened to think of that because, oh gee, look, we have negative 4 there for n. That's not going to happen. So at that point, we just would claim this one to be not a polynomial because of that negative 4. Okay? Glad I had that for an example. I would have messed up your notes. All right, how about h of x? I'll try another one here. Square root of 9x to the 4th plus 16x squared. Okay, how about that one? Well, your gut might say 3x squared plus 4x. Okay, can't do that. Not in, can't take square root across a sum. Okay, it doesn't exist, no rule like that. So this one is not going to be a polynomial. We can't get rid of that radical, so it's just a done deal, not a polynomial. All right, let's just do one more just for fun. How about k of x, something like 15x minus 2x to the fourth. Okay, I'm trying to mess with you just a little bit because I've got our order reversed. Okay, so highest integer or exponent here is a positive integer, so we're cool with that. So we have a polynomial. Is it a function? Yes, it is. Okay, degree, and I was just pointing at it here, is going to be a 4. Leading coefficient is right here with a -2. Okay, so there you go with a couple of examples about polynomials. All right, let me get rid of this and we'll do a little bit more. Hopefully some of this looks a bit familiar. We can also go through some special functions. I mentioned it earlier. If I have something called a zero function, it's going to look like f of x equals 0. Okay, and if I ask you for the degree, okay, this one has no degree, or you could say it's undefined. Sometimes you'll say it would be undefined. You can have a constant function. Okay, constant would be where you have your f of x equals some a value, and this a can't be 0, because if so, then it would be the 0 function. It would be kind of repetitive. Okay, if you have it equal to a constant, the degree is 0. So like f of x equals 5. That would be a constant function. Okay, linear function. Okay, linear function, your old friend the line. F of x equals ax plus b, and again the restriction a can't be 0, because if it was, then we would have the constant function and so on and so forth. Okay, but this one, degree, is always 1. And then the other one for this section is called the quadratic function. Okay, quadratic function, you have f of x equals ax squared plus bx plus c. A cannot be 0, and if it's quadratic, b cannot be, well, I guess b can be 0. Never mind. Just kidding. All right, so the degree of this one, you got it, it's a 2. Okay, so quadratic has a degree 2. Okay, so there's some special types of polynomials. And then lastly for this video, I want to review with you a little bit of your linear functions skills that you've probably talked about in the past, but in case you don't remember. Okay, we'll go through this little set and then we'll wrap it up for this show. Okay, so with linear functions, there's 2 types or kinds of equations that you're familiar with that will be helpful for us. One is your first friend, called the slope-intercept form. Okay, y equals mx plus b. That was probably your friend way back in Algebra 1 days. Okay, another form of a linear function is known as standard form. Standard form, ax plus by equals c. And a restriction on A needs to be positive, and it cannot be a fraction. Okay, that's with A. A's got to be positive and no fraction. Okay, and then lastly, I'll put it back over this way, is called linear function point slope form. Okay, this one is very useful. It involves a point and a slope, thus the creative name, where you can do y minus y1 equals m x minus x1, where m is your slope, and then the point that's involved is your x1 and your y1. Okay, so a couple linear examples. Maybe the question says to you, write the equation of a line And the clues they give, f of -1 equals 2, and f of 3 equals -2. Okay, so using that notation, the question is just telling you, hey, if I plug -1 into an equation, I get out a 2. So it's saying the ordered pair, -1, 2. Same idea here. X would be 3, the y would be -2. Find the equation of the line, okay? So when I'm given 2 points, first thing I'm going to do is find the slope. Okay, in case you need that formula, slope, y2 minus y1 over x2 minus x1, okay? Or you think of that as the average rate of change, okay? Average rate of change when you're looking at slope. All right, so if we do that for these points, and I think of this as x1, y1, x2, y2, we've got like -2 minus 2 over 3 minus -1. -4 over 4 is -1. Okay, so there's my slope. Okay, then to finish and come up with the equation of that line, we're going to say, all right, let's use point slope. Okay, so here's my m. And then you can just pick either one of these points. Makes absolutely no difference whatsoever. Maybe I'll just grab this one because it's the first one listed and fill in. So we'll go y minus 2, -1, x minus -1. Okay? So then minus a minus is just an addition. Distribute our -1 on the right. So -1x minus 1. Add 2 to both sides, and we have y equals -1x plus 1, and that would be your equation. And now we've converted to slope-intercept form. Okay, intercept form, which is handy to graph from, either by hand or on your graphing calculator. Okay, maybe one other sidebar with linear. 2 special lines, a vertical line and a horizontal line. Okay. Vertical is always x equals some number. Okay, and I'd love to ask you out loud, what would the slope be? Like maybe this is just x equals 2. Maybe it's like a VA. We've studied vertical asymptotes. It'd be like a VA. Okay, slope of a vertical line is, you're right, no slope, doesn't exist. Okay, so then horizontal line, let's say y equals some number. Okay, what do you get if you have a horizontal line? Okay, horizontal line, slope is always 0. Okay, thought I'd toss those in there, a couple special cases. Okay, so this was just some introduction into our section about polynomial functions. We have the generic polynomial, some special names of those. We know about degrees, leading coefficients, constants. Then we've talked a bit about linear functions, 3 special forms, slope-intercept, standard, and probably a widely used point-slope form. We've also reviewed how to calculate slope and come up with equation of the line given a couple of points. Hope this was helpful, and see you next time.